So we've taken a really good look at structures as a way to define custom types. The next thing you want to learn about is classes. This is the next level of complexity in terms of defining your own data types. Classes are very similar to structs, especially in Swift, but they have a lot more power. And the biggest difference is a concept called inheritance. The idea is that, much like children inherit genes from their parents in real life, you can have child classes that inherit functionality from parent classes in Swift. And so, in a way, you're creating families of these data types. And it's a very powerful concept that allows you to reuse code amongst other benefits. So, how does this all work? Let's say you want to create a family of data types that handles shapes. Okay, maybe you want to make a 2D paint program or something like that. Well, let's try and design a family of classes that pertains to shapes. So the first thing you're going to want to do is define a base class. And this base class is going to be a generic foundation for the rest of your classes. In our case, we'll call it shape, since we're dealing with shapes. Okay. And for this very simple example, I'm going to contrive some things. I'm going to make sort of a bounding width and a bounding height. And just bear with me, this will all become clear very soon. These are just the width and height that sort of constitute the full dimensions of the shape. Like a shape in theory could be round, it could be parallelogram, triangle, all kinds of stuff. But still, for all these shapes in 2 dimensions, there's going to be a box that bounds this shape. And so this is what we're after here. We just want the width and the height of this bounding box. Okay? And it's defined this way so as to be very generic, so that all the other classes we're about to build can still reuse this idea. Okay? And now for the functions, we could do something like calculate the area. And for this, we're going to return a double, because it allows for more flexibility, as we'll see in a little bit. And this is going to return the area of the bounding box, okay, because that's what we have. The shape itself, if we get more specific, as we'll see later, may have a different area calculation, but this is for the bounding box. Get bounding coordinates, we need some way to return those. So we'll return a tuple, and there's that. And now we create an initializer. And here's where we initialize the values. And there you go, our very first class. And if you look at it, it looks very similar to struct so far, right? Except this word class is in there. So far, really nothing different from what we've seen with structures. You've got some properties you defined, and then you have some methods that work on those properties. And you have an initializer, and all this is old hat to us at this point. And so in the same way that you could create an instance of a struct, you can create an instance of a class. The same concept applies. Just a bit of historical knowledge, you'll hear some people calling class instances, you'll hear them calling those objects. Okay, this is because the term object-oriented programming, that's what historically drove a lot of these innovations. And that's the paradigm we're kind of using here. And so a lot of other languages, classes produce objects. In Swift, the documentation states explicitly they don't like to use the word object, but rather instance. So you can have class instances and struct instances. Just a bit of historical knowledge in case you hear the word object by somebody else or even by myself inadvertently a little later on. So yeah, so let's just define, just to make sure we know what we're doing, define a shape. So this is going to be like a generic shape that takes bounding width and bounding height. Okay. And so we could do things like call the calculate area function. And sure enough, 10 times 10, so the bounding width times the bounding height is indeed 100, so we're doing something right. Okay? And just to refresh our memory of tuples, we might as well print the coordinates. Let's be really explicit here. In reality, we don't need this get bounding coordinates function because these properties are actually directly accessible. But there are certain advantages to making properties private. This is a whole other discussion we'll get into a little bit later. But for right now, just consider it a opportunity to see how functions are being used on classes. But there's really better ways of doing this. So I wanted to print this out. Could do something like this. And I think I messed up here. X slash Y. Sorry, that's my bad. And so now we need this one up here. There you go. So the XY coordinate is printed.